Okay. Um, so solve the LP, that means linear programming problem. If no optimal solution exists, indicate whether the feasible region is empty or the objective function is unbounded. Um, so uh, I guess you have some other cases that you can consider here. Remind me here, are you only allowed to use your calculator for these? Or are you
I
allowed to use Desmos?
um I'm honestly not sure.
Okay. It makes a difference here. Just um, so well, okay. Let me let me show you what I would do to solve these. But I have the advantage of I would use technology, and
Right.
I mean that's where we have a disconnect with reality, which is that you don't have you would have access to this if you were doing it in the other context. But let me new share that and show you what I would do. So do you happen to have the ability to have it pulled up on the web assign on your side?
Yeah.
Okay. So what what I'm seeing here is that we have, and you can graph this way: x plus 2y less than or equal to 3, 2x plus y less than or equal to 3, and x is greater than or equal to 0, and y is greater than or equal to 0. And if you're really clever here, you can see that the overlap, or not clever, if you're not colorblind, you can see that the overlap is in this sort of region here. But it's kind of really it's really difficult to see this overlap. Um, it's even worse on your graphing calculator. So you actually graph, and you might have seen this in class here. I'm gonna uncheck all these. I'm gonna show you what you would graph instead. So you graph the same thing, but you change the inequality, but you have to flip all of them. So this becomes greater than or equal to 3. This second one becomes greater than or equal to 3. Can't type. And then it becomes x. I'm sorry, I don't know why I'm mistyped these. This becomes x less than or equal to 0, and then y less than or equal to 0. And this is a lot easier to visualize. I assume you're seeing my screen still.
Hmm.
And I'm gonna just grab these points here, and that's what you're looking for. So let me snip this in case you want to look at it later on.
Okay.
But effectively, you graph, and there's this whole discussion that in linear programming what it's called. There's a name for all this. So let me go back to the workspace here. So you'll see you've got 1, 2, 3, 4 points to consider here, and you have what's called an optimization min max problem that you're doing. P equals x plus y. So what I would suggest doing is making a table here, x, y, and then p, and you're just looking for the one that's the biggest value here. So like 0, 0 is a point, 0, 1.5 is a point, 1, 1 is a point, and 1.5 comma 0 is a point. P is x plus y. So
Oh.
you're just going to add the numbers. So you're going to get 0 plus 0. So this one is 0. This is 0 plus 1.5, so that's 1.5. This one is 1 plus 1, which is 2. And this is 1.5 plus 0, which is 1.5. So it's a maximum of 2 at 1 comma 1.
Oh, okay. And that's it.
That's it for this one. Now, this one is bounded. It's bounded because you have a region here.
So you graphed all the lines and then saw where, like, is that where they're intersecting or like that picture?
It's the vertices that it of the now Desmos makes this really easy. In your calculator, you'd have to either calculate the intersection of the line, or solve the system to do that.
Okay.
So there's a bit more work to do that, but you this is more about what do you do once you have the number. Um, and or what do you do once you have the graph? The rest of it's not so bad here. So you only get a, oh, you got quite a few here. Okay, so some of these will be unbounded, um, or empty. Maybe not these. Maybe it's the ones in the next. There's always that, like, it's like, well, one week they I don't know how they break this up, but let me grab question 2, snip it in, and then we'll do the same thing here. All right, so question 2, this one is bounded because of these less thans. That tells you that you're gonna sort of, one cuts this way and another cuts this way, and you're gonna get this sort of region again here, most likely. Okay, so I'm gonna graph this over in Desmos, and then I'm gonna snip in the result now that you've seen kind of how to do this, and then we can work through it. So it's x plus 4y, but we're gonna do greater than or equal to 19, and then we're gonna do 3x plus y greater than or equal to 13, and then x less than or equal to 0, y less than or equal to 0, and I'm gonna grab those vertex points here. That way they're very clear. You still have to show the origin, even though it's always 0, 0. They do expect to see that. So let me snip that graph in, and you'll see what I'm talking about here. So that is coming in right now. So like this one here, this is a decimal, but it needs to be converted to a fraction. It's 4 1/3, so that's 13 over 3. In case I don't recall if it said a round or not. So now you just have to try these points. You have to try each of these points into the objective function. The objective function this time is x plus 2y. So I might make a table again. We'll go x, y over here, and then it's x plus 2y. So the first one, I mean, you can do it if you want, but it's 0. Okay. It's often the corner point, but not always. So you have to be very careful there. So the 0, 4.75 is 0 plus 2 times 4.75, which is 9.5. Then the 3, 4, that's 3 plus 2 times 4, so that's 11. And then this one's 13 over 3, comma 0. 13 over 3 plus 2 times 0 is 13 over 3. So this one says to maximize, I think, maximize. So we're looking for the biggest number. That's here at 3, 4. Three comma 4, and it's, what was it, 11? Can't remember the numbers. Okay. Did you already get a lesson on this? Is this all a repeat of what you
Did it
saw in
on
class?
Thursday, but like, to be honest, it was like the one class we did, and I was working on an assignment in the background. So
Sure, understood.
Yeah.
I get it. So
Very easy to get distracted during online class.
yeah, I know what you mean. I know what you mean. Okay, I'm gonna skip. I'm gonna go to 4. I'll probably have time to get back to all of them, but I want to. This one's a little bit more difficult
Okay.
because of the decimals. If you were doing this by hand, you could clear the decimals. You'll see that shortly when I snip this in. You can always clear decimals by multiplying by 10. You don't have to, though, because your calculator will handle all of that without issue. So let me do the same thing here. I'm gonna just graph this again. So it's 1.2x plus 0.6y greater than or equal to 6, and 0.12x plus 0.24y. I'm flipping the inequality, greater than or equal to 1.2. And then we have 5x plus 5y, 5y greater than or equal to 30. And then the last one there, x less than or equal to 0, y less than or equal to 0. Okay, so this one actually has quite a few more of these vertices to look at. Get that in there. Okay, so snipping it in, and you'll see what I mean shortly. I would beg the instructor to let you use something like this because it just
Yeah.
makes it so much cleaner.
Yeah.
Okay, so you notice here, like if you were trying to do it, if you didn't flip these inequalities, you'd have a really hard time figuring out where the overlap is,
Uh-huh.
and looking for the white space is kind of clear. So you're maximizing. What are you maximizing? You're maximizing p. P equals 3x plus 2y. So I just make a table. Like you know right away that it's not 0 0, but it's good practice not to avoid any points. It's also good practice to kind of have a path around this figure. Like are you going to go clockwise or counterclockwise, or just have a way where you don't miss any. So 0 0. So that's 0 here. 2 4. I'm sorry, 0 5. I almost did what I said. That's 3 times 0 plus 2 times 5. So that is 10. Then we got 2 4. 3 times 2 plus 2 times 4. 6 plus 8 is 14. So we got a new winner. 4 comma 2. 3 times 4 plus 2 times 2. That's 12 plus 4. That's 16. And then we got 5 comma 0. 3 times 5 plus 2 times 0, which is 15. So our winner here is 4, 2, 16. 4, 2, 16. Okay. Let me enter that value. I've been entering the ones we've done into WebAssign, and then we'll move to the word problems, story problems next. And these are about. This is where you're really gonna, if you can do these for the exam, I assume that you're going to get some word problems. We got to set up the equations,
Hmm.
and then do the exact same thing I just did, but we got to set up the equations here. Okay, rough ink makes dog food out of chicken and grain. So again, those are your variables x and y. Chicken has 10 grams of protein and 5 grams of fat per ounce, and grain has 2 grams of protein and 2 grams of fat per ounce. A bag of dog food must contain at least 232 grams of protein and at least 162 grams of fat. If chicken costs 11 cents per ounce and grain costs 1 cent per ounce, how many ounces each should use to minimize cost? So I often find it's easiest to write the function that you're trying to maximize or minimize. P is commonly used. It's 0.11 y plus oh x. Sorry, wrong letter. Plus 0.01 grain costs. Wait, chicken is y, isn't it? Yeah, that's weird. Um, it's weird that they gave two animal. Okay, that's a y plus 0.01x. And now we go to the constraints. So the ones that are, you actually would write them in this order first. X has to be greater than or equal to 0. Y has to be greater than or equal to 0. They always come at the end, but truthfully, you know that you wouldn't have negative values, so you usually do them first. Chicken has 10 grams of protein. So there's going to be a protein equation because they have to have at least 232 grams of protein. So 10y plus, go to find the 2 grams there, 2x. It's really weird that they've done this out of order. Has to be greater than or equal to 232. And then the at least here means 162 for the fat. So that's 5y plus 2x. So if you notice, I stumbled over this x and y quite a few times. I'm pretty sure that this is that they should have flipped the order, but they didn't. If you get this problem, you have to be very careful because it'd be easy to put the wrong number in for the wrong answer. So let me graph this, and then I will snip it over, and you can see what we're looking at.
Yeah.
So we have 10y. It's 2x. This time, instead of it being greater than or equal to, it's going to be less than or equal to. And and that's going to be 5y plus 2x less than or equal to 162. X is less than or equal to 0. Y is less than or equal to 0. This does create a new sort of visual that you haven't seen yet. I'm going to grab it here. There it is. Okay. Snipping that in shortly. So this one is unbounded, but it does have a solution because actually it doesn't say that. It says that it could not have a solution. This one is unbounded because the region you care about, like this up here is called the feasibility region. It just means these are the possible places that work. But you have these constraints down here. This last one didn't snip in. I don't know why. It's 116 comma 0 down here. So notice it's in the previous problems when you're maximizing, you get a nice shape. When you're minimizing, you get kind of this open region. So we have to take our x, y's and our profit function, which was, what was it? It was 0.11y plus 0.01x. So one of these will give us the right value. If you have a calculator handy,
Yeah.
it'd be good for you to check me on these. Let me grab mine. Okay, 0.01 times 32.4. All right.
3.564.
I get 0.324 for the first one. 46 comma 14 for the next one here.
Oh wait, did you multiply?
Oh, nope, I grabbed the wrong number. I made the mistake there, like you said. Yeah, so it's 0.11 times 32.4. So 3.564
Then I got 1.68.
for the next one.
Yeah.
Okay. How about for the last one there? Looks like it's 1.16.
Yeah, I got that.
Okay, so the chicken is y. Y is so we got 0 and 30. I've seen this problem so many times. I guess they never change it. Okay, it didn't like 32.4. What did I grab something wrong? 10 and 2, 5 and 2, 232, 162. Yeah, it doesn't like 32.4. I wonder if it's the other number. How many submissions do you get?
Like 10 or something. There's a lot.
Okay. Well, the answer is this one. So something must be wrong with. I mean, there's something going on there that's weird. I would ask your instructor to look at this problem. There's either a mistake or
Okay.
something else that's
I
worth
can.
going through.
Is there like a ask your teacher button or something?
There is.
Okay.
Um,
Or I can say something in class.
I don't know if you probably don't have participation points, but that would be a good one to bring up. Say,
Yeah. Okay.
variables seem weird. Okay. Okay. Next one here is I think this one's more standard. Vanilla is X, continental mocha is Y. They give you the thing that you're trying to maximize. So they say you get a profit of $3 on each quart of vanilla. So your P is 3X, and you get 2Y for mocha. You know that whatever you do has to be these constraints, and then see if you can write the equations for the eggs and the cups of cream. Give that a try, please.
It's similar to like what we did in the
Yes.
last unit, right?
Yes.
Okay. Um, is it 2x plus y equals 500 and 3x plus 3y equals 900?
So the eggs equation is 2x plus 1y less than or equal to 500, and then 3x plus 3y less than or equal to
Oh yeah,
900.
I just didn't do the less than or equal to.
Okay. Yeah. So let me graph that, and then I'll snip in the feasibility region so you can see what it looks like. Um, right. So this, and then we get x less than or equal to 0, y less than or equal to 0. Okay. So there's again 4 points. I'll just say again that I'm really glossing over the challenge associated with finding the intersection on a graphing calculator. It's something you might want to do for 1 or 2 problems to be comfortable finding those points. Um, so this does it so nicely that it makes it like where you almost forget how to do it on the real exam. So the profit function is 3x plus 2y, or the thing we're trying to minimize here. No, maximize. We're trying to maximize. So we're going to start with 0, 0. And we know that that's in the wrong place. Um, we know that that first point doesn't do anything for us. 0, 0 gives you 0. So now we're going to try 0, 300. So that's your profit is 2 times that. That's 600. Then you got 200, comma 100. So that's 600 plus 200. That's 800. Looking good. And then we got 250, comma 0. That is 750. So it looks like your winner here is 200, comma 100.
Okay.
All right. So after I enter these answers, we have a choice. We can go back and do. I think I left one of them. What did not complete? Can
Just
do
the one
that.
though.
Number 3 or something. You can either do that or we can do it and move on to the next section, or just move on to the next section. Your choice.
Well, is the third? Is that the one that I didn't ask the teacher about?
No, that the one I asked you about is correct. I mean, I entered the correct answer, but it's very inconsistent with the labeling.
Oh, we can just do this one and then go on to the next section.
Great.
Yeah. Honestly, I might. Do you meet on the weekends, like on Saturdays?
Sundays, I could probably, if you wanted to meet on Saturday, we could probably
I know,
find
or
a
I
time.
can see if there's like a Friday time. So I'm going out of town on like Monday and Tuesday next week, so I want to like get the math homework out of the way, you know.
Okay. I mean, my
So,
preference would be sometime between now and Thursday.
yeah, I'll try. I'll do that. Yeah, maybe like
There's plenty of open spots
yeah.
between
I'll
now and then.
probably be free on Thursday.
Okay, so this one, let me just go to Desmos here and just graph it. It's oh, this one's going to end up being unbounded, but I want to show you why. 0, maybe not. 3x minus 2y is equal to 0. Oh yeah. Um, Okay, so home. All right, snipping this in. So when you're trying to maximize something, you need a closed region. There's some theorem that says that, but and this is the first problem where this isn't closed. Like this thing goes out forever, and that's bad. This is really bad because in all the other problems we've done, see how this was a closed figure. This one's not. So when you're trying to maximize something, you need a closed figure, and you don't have that here.
Mhm.
So that means that
Does that mean it's unbounded?
yeah, it's unbounded if the function is and empty if the region is empty. So I actually don't know what you're supposed to put into these boxes. Um, so I'm trying to figure out what to tell you to put it here. It's so confusing. What enter empty if the region is empty, but which one? Enter unbounded. So it is unbounded. I think you put that in both. I think unbounded goes in both because that is what's happening here.
Yeah, that's what I was guessing.
Didn't like that.
Hmm. For both of them?
Didn't like it for both of them.
Hmm.
Uh,
What about empty?
yeah, I'm gonna try that now. This is why it's like so important to do this. Didn't like that either. um, that is really. Oh, you know what? I missed a constraint. I'm so sorry. I missed the x plus y. Okay, that's what I missed. I'm so sorry here. I got it in now, and it'll be clear. Boy, that was silly. Don't do that on the test. Okay, so we're gonna get rid of this picture, and we're snipping the correct one. Um, I was so used to doing two, it just missed it there. So it does bound it. So this does work because you got this nice
Oh.
triangular, and this one's
Uh-huh.
0, 0, which I didn't grab. So you are maximizing p equals 3x plus y, and we have only three choices here. So 0, 0, well, that's almost never the case. 2 comma 3, it's 3 times 2 plus 3, that's 9. And then we've got 3 comma 2, that's 3 times 3 plus 2, that's 11. So this is our winner here. And that's I'm glad you get more than 2 submissions because I would have messed you up on that. Okay, that takes care of that section.
Okay. Yeah, we can go into the ones due on the 23rd.
Great. 6.3 is next. You've got 3 sections due on that day.
Yeah.
Okay.
Some of them only have, the other ones have like a few problems, I think, but
Yes. Oh wow.
it's weird. I don't have homework for a while after the 23rd. Like, do I have another exam already? I don't. It's weird.
Should be right before spring break if there is one. I don't think they're doing. Okay. So number 2. Okay, so number 1 is exactly like what you had in the previous section. So we're not going to do that. I mean, we can, but not right this second. This one is obviously much more complicated.
So it's the same, but it's more complicated, basically.
Well, 3 variables. So if you recall from geometry,
Oh,
you're now in 3 space here,
okay.
and the issue is that I don't actually know how much depth they go in here. So what you tend to do here is you tend to just solve this system,
Mm-hmm.
and that usually is the answer, but not always. trying to decide here how to best help you on this. So like I don't want to get like there's other discussion here, like these three equations. The first two are equations of a plane, and a plane
Mhm.
looks like that, and another, let's just say another plane intersects it. It looks, it looks something like that. So they intersect in a line. Well, this is a line too, which means that they only intersect in one place. Um, there. So you're guaranteed that that could work. But the whole discussion we had in the previous section where you have this feasibility region, it still applies. But I think the way this works in your classes is if you literally just solve this system, that's going to be your x, y, z. So what I'd like to do is just have you solve the system. I'll do the same here. Use your calculator, use matrices, use RREF to do that. So let me,
So you kind of just ignore the
you treat it as an equal sign. And we're going to see how far this gets us to go before
so
before
it's
I.
so it's 4 or 3 times 4.
Yes, it's a 3 by 4. Okay, so that didn't work. Did I not solve that correctly?
Got 16. Yeah, I got the same thing.
Yeah, it didn't like that, which I don't know why. Let's see. Let me see what the practice another. Um, so this one has show answer 503. Okay. Um, yeah, so this is where it's way more complicated than I guess what I would what I would starting to think it would be. So the um the maximization occurs at these sort of edge cases, which is like well, x and y, like if x is 0, y has to be 20, or x is 20 and y is 0. So yeah, what I just said is true. Like this is one of those points to consider. It's not the only one. And this is where it gets really tough. Like there's, well, okay, let's say x is 20 and y is 0. Well, then what is z? Well, z looks like it has to be, according to this equation, 8, because 20 plus 0 minus some number has to get you back to 12. Is that can you kind of follow that? But
Yeah.
what if x is 0 and y is 20? Well, then it's 20 minus, and that looks like it's 8 again. Okay, but this one actually doesn't work in the second equation because um, 20, 0 plus 2 times 20 is 40, plus 8 is bigger than that. So this one's out. So that means, and that's kind of that's as far as we need to go, because um, this one we found is an edge case. This also works. So we have to try it as well. And it ends up that it does end up being correct here. 20 comma 0 comma 8. So your P here is 14 times 20 plus 12 times 8. So with this one, your P is 14 times 20 plus 10 times 0 plus 12 times 8. So I'm sure we'll need a lot more discussion on this. But that's 280 plus 96. Looks like it's 376. Didn't like that either. My goodness. that followed from the solution that they gave 20. Okay, let me just choose another section here if you're okay with that,
Yeah,
and
that's fine.
make some more progress, and I'll try to figure out why these aren't working as well as I'd like them to. Um, these are these are like the ones we just did, but that's okay. These are worth spending some time on. So, all right, this actually continues much more nicely from the previous set. So we're maximizing p equals 9x plus 6y subject to, and you've got all these constraints here. So this is again where we need to graph it, and we're gonna get some sort of region or whatever, and then we're gonna get some points here um, to look at. Is that kind of clear about how to
Yeah,
do that?
yeah.
Okay. Um, 2 and 3 are the same, but let's do 2, and then we'll go to 3 and get the well, 3 is another one here. Where'd you do that? So let's do this one. Go grab the graph of this. So we got x plus 3y less than or equal to 6 minus x plus y greater than or equal to 4, 2x plus y greater than or equal to 8, and then x is less than or equal to 0, y less than or equal to 0. Okay, so let me grab all these edges. All right. So if you were doing the homework on your own, you have enough guesses that you could try to find x and y by just plugging these in until you got the right one. We can do a little better than that because we can
Yeah.
probably guess these here, but it's 9x plus 6y. Um, okay, so it's almost never these ones at the edge here. So we're going to just ignore those for the moment. So this first point that we might consider is 4/3, comma, this is 5 is 15/3, so that's 16/3 here. So 9 times 4/3, that's 12. 6 times 6/3, that's 32. So it looks like this is
40,
44.
44, yeah.
And then we got 3.6 comma 0.8. It's going to be close, but I think the 44 will beat it. Let's check that. So it's 3.6 times 9 plus 0.8 times
37.
37.2. So let's go with the first one here and see what you got. So we got 4/3, comma 16/3, um, and that's 44. Okay. The next two are like this 3 variable ones. I'm gonna have to look a little bit more and figure out why those aren't working the way I expected them to. Look at 15.2 now and see what that is. See what, okay, wow. Um, this is a total diversion from what you've been doing.
Mhm.
So let me, it's probably better if we go back, not cover this tonight. It won't mean much. Let me go back to one of these other sections here. So let's go back to 6.3 and see if we can make some sense of this. So, okay, let's do number 1. Try that. Okay, so this is number 1 on 6 point. Okay, so this one's got 2 variables. It's best to just go and graph this again, which I'll do. So it's x plus 2y greater than or equal to 11. And then we got minus x plus y greater than or equal to 7. X plus y greater than or equal to 7 again. And then we got x less than or equal to 0. y less than or equal to 0. We have this nice region that's bounded by all these points, which I can snip in now. Um, really makes a huge difference. So I wonder if Desmos has a. I never thought to do it, but it's probably got a 3 by 3. So we're gonna check all these points into the optimization function, and the optimization that we're doing in this one is 2x plus y. 2x plus y. So we got ordered pairs here. We got like, we won't try 0, 0. It's rare when it's one of those. Let's try 3, 4. 3, 4 is 2 times 3 plus 4. So that's 10. And then we'll try this one over here, 7 comma 0. 2 times 7 plus 0. Well, that's 14. So that looks to be the winner there.
Mhm.
All right. So 14 and then 7 comma 0. Okay. I'm really bothered that these aren't just finding the solution, and there's more to it. Because the next section is kind of related to this, but let's look at this one more time here. Number 2 here. Okay, so we're trying to maximize this function subject to these constraints here. So if we add the first two together, let's try this another. If we add the first two together, you get 2x plus 3y is less than or equal to 44. And then you get x plus y is less than or equal to 20. So I'm going to try graphing these and see if we come up with something similar to what we've been doing in the previous problems. Hopefully this has got a nice bounded position here. 2x plus 3y greater than or equal to 44. And then x plus y greater than or equal to 20. Okay, so far that's looking good. And then x less than or equal to 0, y less than or equal to 0. Okay, so this we got something here that could be useful. So let me get this snipped in. Okay, so notice this creates a reasonable region here. My preference would be to try these whole numbers first, like 16 and 4. But I thought we did that originally. Didn't we say, okay, 16,
So,
we did 16, 4, and then 8. I didn't like that. Okay. Well, I'm going to check Chegg and see what they have to say on these. Maybe it'll shed some light on what's supposed to be done here. Okay, so this one says that they used Excel Solver, which is totally reasonable to do, but maybe not in your class. So I guess that's where I want to leave you is
yeah, it's fine.
find out if your instructor is going to allow you to use an optimization thing for this.
Okay.
Because the next problems in this section are very much more difficult than this one. They're 4 variables, and then it's got some other stuff going on. So yeah, I guess, and these can all be done in Excel very quickly, but we would need to know that. So, and probably want to do that before you schedule a lesson, because I mean, I can get you the right answers. I just, in Excel, it won't help you with.
I'll just see how she teaches during class.
Sounds good. I also don't think you're going to have all 3 of these sections due next Tuesday. You're probably going to have, you might find that you're already sort of there. They tend to push out the sections, especially that 15.2. It's totally something new.
Okay.
Anyway, thanks for scheduling, and I'll send you out the notes and the link to this screen sharing here shortly.
Okay, sounds good.
Have a good
Thank
night.
you.
Bye now.
Bye.